Two 2001 images from the Mars Orbiter camera on NASA's Mars Global Surveyor orbiter show a dramatic change in the planet's appearance when haze raised by dust storm activity in the south became globally distributed. The images were taken about a month apart. Image credit NASA. Caltech's a new study using data gathered by NASA's Mars Reconnaissance Orbiter (MRO) during the Red Planet's most recent global dust storm in 2007, suggests that such storms play a role in the escaping of gases from the planet's atmosphere. That process transformed the warmer, wetter climate of ancient Mars into the arid, frozen conditions found on the surface of the Red Planet today. We found there's an increase in water vapor in the middle atmosphere in connection with dust storms, said Nicholas Heavens of Hampton University, Hampton, Virginia, lead author of the report in Nature Astronomy. Water vapor is carried up with the same air mass rising with the dust. NASA's Hubble Space Telescope and the European Space Agency's ESA Mars Express orbiter have previously detected a link between the presence of water vapor in Mars' middle atmosphere, approximately 30 to 60 miles 50 to 100 kilometers high, and the escape of hydrogen from the top of the atmosphere, but mostly during years without the dramatic changes caused by a global dust storm. NASA's Mars Atmosphere and Volatile Evolution MAVEN spacecraft arrived at Mars in 2014 to study the loss of atmosphere gases into space. If a global dust storm occurred on Mars this year, it could be studied like never before using the combination of spacecraft currently at Mars. It would be great to have a global dust storm we could observe with all the assets now at Mars, and that could happen this year, said David Cass of NASA's Jet Propulsion Laboratory, Pasadena, California via a release. Cass is a co-author of the new report and deputy principal investigator for the instrument that is the main source of data for it, MIO's Mars Climate Sounder. Artist's depiction of NASA's Mars Reconnaissance Orbiter above the Red Planet. Image credit James Vaughan Spaceflight Insider. A global dust storm on Mars could adversely affect ongoing missions. The solar-powered Opportunity rover would have to hunker down to save power, and parameters of the upcoming InSight mission would need to be altered for safe entry, landing and descent in November. The global dust storm would also lower visibility for all of the cameras on the rovers and orbiters operating at the fourth planet orbiting our Sun. Observations of Mars over several decades have shown a pattern of multiple regional dust storms occurring during the northern spring and summer. During most Martian years, which are almost twice the length of Earth years, the regional storms dissipate rather than expanding into a global dust storm. Global dust storms have covered the Red Planet's face in 1977, 1982, 1994, 2001 and 2007. The next Martian storm is expected to start this summer and continue into early 2019. The Mars Climate Sounder MCS on MRO scan the atmosphere to directly observe dust and ice particles. It can also indirectly measure water vapor concentrations and its effects on temperature. According to the new study, MCS data show small increases in middle atmosphere water vapor during regional dust storms and a sharp rise in the altitude reached by water vapor during the dust storm in 2007. While using newly refined analysis methods for the 2007 dataset, scientists found an increase of more than 100-fold of water vapor in the middle atmosphere during the global dust storm. Before the MAVEN spacecraft reached Mars, many researchers expected to see lost hydrogen from the top of the atmosphere happening at a fairly steady rate, with fluctuations related to changes in the solar wind's flow of charged particles from the Sun. Data from MAVEN and Mars Express have instead shown a pattern more closely tied to Martians. Heavens and his fellow researchers have presented the hoisting of water vapor by the dust storms as a possible key factor in the pattern of hydrogen loss from the top of the atmosphere. MAVEN observations during a global dust storm could increase our understanding of the link between dust storms and the escape of gases from the atmosphere. As Mars Reconnaissance Orbiter flies about 180 miles 300 kilometers above Mars' surface, it almost continuously scans the surface and edge of the atmosphere with a Mars Climate Sounder to build up a four-dimensional view of the temperature, pressure, and composition of the bottom 80 kilometers 50 miles of Mars' atmosphere over the course of one Martian year. Image credit NASA. Caltech tagged Curiosity lead stories Mars Express Mars Reconnaissance Orbiter MAVEN Opportunity. Jim Sharkey is a lab assistant, writer and general science enthusiast who grew up in Enid, Oklahoma, the hometown of Skylab and shuttle astronaut Owen K. Garriott. As a young Star Trek fan, he participated in the letter-writing campaign which resulted in the Space Shuttle prototype being named Enterprise. While his academic studies have ranged from psychology and archaeology to biology, he has never lost his passion for space exploration. Jim began blogging about science, science fiction and futurism in 2004. Jim resides in the San Francisco Bay Area and has attended NASA socials for the Mars Science Laboratory Curiosity rover landing and the NASA LADEE lunar orbiter launch.